We're going to have a look at some partial fractions. So a partial fraction is when we've got a fraction like this, which looks quite complicated, and we want to split it into its constituent parts. So what do we mean by that? So we see here that we've got some algebraic fraction, but we notice that its denominator has 3 different factors. So it's possible that we could have written this as the sum of 3 separate fractions, which when we add them together, have that as their common denominator. The simplest version of that would be written like this. We've put some constants in here, a, b, c, because we don't know how many fractions with the denominator 2x minus 1 we'd have, or any of the other denominators. So we just put some constant in which we can now look at how to find. Importantly, this is always equal to that. These would be equivalent statements. It's not equal to it for some particular value of x which we can solve. A fraction written like this could be written as 3 separate fractions all added together. So how can we figure out the values of a, b and c? Well, very first step, like we often do in A-level maths, is remove the denominator. Everything's easier once you eliminate the fractions. So I'm just going to multiply through by this denominator. On the left-hand side, I'll be left with 17x minus 19 is equivalent to... Now, when I multiply this fraction by this denominator, the factor of 2x minus 1 will cancel out, and I'll just be left with a lots of x plus 3, x minus 2. Similar for b. The x plus 3 will cancel out, and I'll be left with 2x minus 1, x minus 2, and likewise for c. X plus 3, 2x minus 1. Okay, so we've got rid of the fraction. It looks a little bit nicer. Now, because I know this is equivalent to this statement here is exactly the same statement as this here for any value of x. I can choose a nice value of x. I'm going to choose a value x is 2. By choosing x equals 2, I see that I'm going to have 0 lots of a left, because x minus 2 will equal 0. That whole term will disappear. Similar here, my b will completely disappear, because I'll have a 0 there. The only thing I'll be left with is c. So we just say let x equal 2. That's going to give me 34 minus 19 is 15. No a's, no b's. I will, however, have 5 times 3, lots of c. I'll have 15 c's. C will equal 1. If you start getting some bad fractions here, like 4/7 or something like that, it's worth just rechecking your calculations. You'll almost always have nice numbers. Worst case scenario, you might get a half or a third. Usually they're integers though. Any horrible fractions, just have a quick double check. You could have made a mistake. Now we can choose another value. I'm going to choose x equals a half. Again, I can eliminate most of these, so my b's and my c's will now disappear. I'll only be left with a's. So if I look at my a's, I've got 7 halves times minus 3 halves, which I hope is that. And on the left-hand side, I've got 17 over 2 minus 34 over 2. I'm going to need to write that one down. Which gives me 21 over 2. Again, it's nice I can see that factor of 21 is going to cancel. A is equal to minus 2. Nice value, I can probably trust it. And then finally, we'll let x equal minus 3. Our final value, now I can eliminate my a and my c, and I can find my b. So I get 17 times 3, which is 51. 51 minus 19 is 32. And number of b's, I'm going to get minus 6 minus 7 times by minus 5. And as I look at that, I see I'm getting b times 35. It's going to be a horrible fraction. I've probably made an arithmetic error. Quick little check. I've accidentally substituted in positive 3 in rather than the minus 3 I said I would. So I can just change that. That's not 32. That's actually 70. Minus 70. Minus 51, take away 19. Now I've got a nice number. B is equal to minus 2. As soon as you see that you've got a nice number, you can say, yep, I'm confident with that. So my B is minus 2. As I say that, I've just realised that should have been minus 21. There we go, positive 2. Okay, I can now write out my answer. So I know that my A is 2, B is minus 2, and C is 1. So that was in fact equal to 2 over 2x minus 1 plus, minus 2 over x plus 3, and plus C was 1. 1 over x minus 2. Okay, that's how we can split one complicated fraction into its constituent parts. We call that splitting it into partial fractions. These will be much easier to work with as we go on. Once we learn about the binomial expansion, we can do a binomial expansion of each of these in turn, and therefore find the binomial expansion of that. Similarly, this is much easier to integrate because we've got 3 simpler terms than trying to integrate that. We use all of those skills later on. Multiply through by the denominator. Choose nice values of x that eliminate 2 of your terms, and then work through to find out what they are. If you get horrible numbers, just check for an error. Also, just be very careful of sign errors. They're easy to make. Hopefully that's all okay.